أهلا بكم طالبات وطلاب الصف الأول الإعدادي. النهاردة هنبدأ أول دروسنا في الماث تحت رعاية وإشراف وزارة التربية والتعليم. So, welcome everyone. Today we are going to talk about the first lesson in math. First of all, let me remind you what we studied before and already we needed today. Do you remember the sets of numbers? First, we studied the counting numbers, which are 1, 2, 3, and so on. Second, the set of natural numbers, which is n, and n equals 0, 1, 2, 3, and so on. Then we learned also about the integers, and the integer set is z, and z equals all the positive numbers, which are 1, 2, 3, and so on, then 0, then all the negative numbers, which are negative 1, negative 2, negative 3, and so on. So today our lesson is rational numbers. It's a new concept for us. Let's have a look on it. The rational numbers are numbers can be expressed as A over B, where A and B are called two terms of the rational numbers. We can express the set of rational numbers as the following. The set of rational numbers is Q, and Q equals X, and X equals A over B. When A belongs to Z, B belongs to Z, and B is not equal to 0. That's all about the definition of rational numbers. Then let's move. Here we have some exercises for the rational numbers. The number 1 is 1 over 2. It's a rational number because 1 and 2, both of them belong to Z. Then negative 5 over 8. Even if I have negative sign, they are still in the rational numbers. 3, we can write 3 as 3 over 1. And 0 also we can write it as 0 over 1. Then 3 and half, we can rename it to multiply 2 times 3, which is 6 plus 1, which is 7 over 2. Then the decimal and the whole numbers and percents. Here we have the first hint. All the decimal numbers are rational numbers. How do we know that? Because any decimal number or decimal fraction can be expressed as A over B, where A and B are integers and B is not equal to 0. For example, 2 and half. How many decimal places are there in 2 and half? Just one decimal place, which is 5. And as we know, we can write 2.5 as 25 over 10. Why 10, girls and boys? Because 10, it has 1 0. And the decimal here, it has also 1 decimal place. So the number of decimal places should be equal to the number of zeros. Can I rewrite 25 over 10 by another way? Of course, yes. We can multiply both terms, numerator and denominator, by 10. So it can be 250 over 100, and so on. To multiply it by 100, by 1000, and so on. Also, 0 over 7 is a rational number, and it can be written as 7 over 10. Then, the second hint is for all percents are rational numbers. How do we know that? As you know, the percentage sign means over 100, and we have to focus on that. Why? Because any number can be written as percentage, we can immediately write it over 100. Here we have 15% is a rational number, can be expressed in the form 15 over 100. And as I said, the percentage sign means over 100. The third hint is for all integers are rational numbers. All integers. Who can remind me what is the meaning of integer? Integer means any number can be positive, 0, or negative. And I can write any number of them over 1 because all of them doesn't have a denominator. And in this case, we can write it over 1. For example, 3, I can write it as 3 over 1. 0 the same, 0 over 1. Negative 1 is negative 1 over 1. That's all about integers. So Z is a subset of Q. Since N is a subset of Z, then N is a subset of Z and subset of Q. Some examples for integers. 3 is an integer number. I can write it as 3 over 1, or we can write it by multiplying both numerator and denominator by 2 to get 6 over 2. So it's up to you to multiply it by any number, but you have to know that when you multiply the numerator, you have to multiply the denominator by the same number. So in the first case, it's 3 over 1. It can be written as 6 over 2. Then it can be written as 9 over 3. Also the 0, it can be written as 0 over 1 or 0 over any number. The negative is negative over 1, negative 16 over 1. Here we have remark. Each integer is a rational number, but not each rational number is an integer. We cannot do the opposite. How do we know that? Any integer, it's a whole number, just positive, 0, or negative. When I put the denominator 1, that means it can be written as a rational number. Let's do the opposite now. The rational number is 2 over 3, for example. Can I write it without denominator? Can I cancel 3? Of course, no. How can we cancel 3? Still, we have denominator. The integers have 1 as denominator, so keep that in mind. Then, each integer is a rational number. Like what? Like 12 over 6. 12 over 6, I can rewrite it as 2 by simplifying it, by dividing 12 and 6 by 6. Both of them, I can divide them by 6. So here we have a hint. 12 is divisible by 6, and the result is 2. Yes, as we said right now, here we have 12 and 6. We can divide both of them by 6. The second one, 25 over 4. My question is, can I divide 25 and 4 by the same number? Of course, no. So in this case, I don't have an integer number. It's a rational only. That's what we need to focus on it. Next. Example 1. Show why each of the following is a rational number. The first example is 3 and 2 over 5. We can rename it as 5 times 3, then add 2. So 5 times 3 is 15, plus 2 is 17, and we have to write the denominator as it is, which is 17 over 5. Second one, negative 0.17. I can write it as, let me remind you how many decimal places are there here. 1 and 7. I have only 2 decimal places. So what is our denominator? The denominator should be 100. Why I didn't put 10? Because 100, it has 2 zeros, and already we have 2 decimal places. So you have to focus on that. Here we have the number of decimal places should be equal to the number of zeros. So we can write negative 0.17 as 17 over 100. The third one, 0.006. The same question. How many decimal places are there? Let's count how many digits to the right of the decimal point. Here we have 006. So actually, I have 3 decimal places. So my question is, I have to put this 6 over 10 or 100 or 1000. And keep in mind, we have 3 decimal places. Yes, we have to put it above 1000 because 1000 has 3 zeros. The last one, 27%. 27%, the percentage sign, it means over 100. So I can write it as 27 over 100. And as you can see, 27 and 100, both of them are integers. So here we have the answer. Example 2. If x an integer, write the required condition to make each of the following a rational number. All we have to do here is looking at 2x. Look at the denominator. The denominator in the first example is 2x. So we have to write 2x is not equal to 0. Is not equal to 0. That gives us x is not equal to 0. The second one, 7 over x minus 3. What do we have to do in this one? Also, we have to write x minus 3 is not equal to 0. So let's solve it as an equation. How can we get x? We have to add 3 for both sides, and then we will get x equals, or x is not equal to 3. That we have to avoid it to be a rational number. Example 3. If the rational number x minus 3 over x plus 3 equals 0, find the value of x. Here we are going to do the opposite. We are going to look at the numerator. So what do we have to do one more time? We have to look at the numerator. X minus 3, I have to put it equals 0. Let's solve it as an equation. X minus 3 equals 0, so I have, let's do it mentally. X minus 3 equals 0. So what is the value of x? What minus 3 equals 0? It's easy for us. 3 minus 3. So the value of x is 3. Now, example 4. Put each of the following numbers in its simplest form. What does a simplest form mean? Here we have to divide by the same number both numerator and denominator. So let me ask you, what about 8 over 12? Which number I can divide by it? I have to divide by 4. So 8 divided by 4, which is 2, and 12 divided by 4, which is 3. The solution is 2 over 3. The second one, negative 12 over 36. The same question. What is the common factor? What is the greatest or what is the highest common factor? 12 and 36. I have to divide both of them by 12. When I divide 12 by itself, equals 1. And 36 divided by 12 is 3. So the solution is negative 1 over 3. Example 5. Let's do it on the board with each other. Example 5. Write each of the following numbers in the form of percentage. All we have to do in this case, we have to convert the denominator to be 100. The first example. It's 9 over 20. My question is, can I convert 20 to be 100? Yes, of course. I can multiply 20 by 5, and you have to multiply the numerator also by the same number. So it can be written as 45, it's 9 times 5, and then 20 times 5 is 100. And as we said, over 100 means percentage sign. So I have to put 45. That's all about the first one. Now the second one, 17 over 1,000. Oh my God, I have more than 100. So in this case, we have to write the same number, which is 17 over 1,000 times 100 over 100. I didn't change the value, by the way. Why? Because what we multiplied and divide by the same number. Then try to simplify. I'm going to cancel 0 up and 0 down. 0 up and 0 down. Now we have 17 over 10. How many zeros are there? Just 1 0. So I have 1 decimal place. Here it is. 1 decimal place. I have to count the decimal places starting from right. Over over 100. It's very clear for us now. We got over 100, so immediately put the same number as it is, which is 1.7, then percentage sign. Next, example 6. Write each of the following numbers in the form of a terminating decimal. What does a terminating decimal mean? Here we have to write the denominator as 10, 100, 1000, and so on, powers of 10. In the first case, it's 2 over 5. Can I convert it to be 10? Yes, of course, by multiplying it by 2 and here also by 2. So it becomes 4 over 10. That's what we need. We have the second one. 4 over 10, it has only 1 0, so 1 decimal place, which is 4, and then 0.4. The second one, negative 3 over 8, the absolute value of negative 3 over 8. Let me remind you, what does the absolute value mean? It means get this number out of the absolute value without any sign. So it becomes a 3 over 8. And as we know, 8, we can multiply it by 120 to be 1000. So I'm going to multiply 3 by 120. It becomes 375 over 1000. And focus with me, please. Here we have 3 zeros, so I have to put 3 decimal places. Start from right. 1, 2, 3, 5, 7, 3. And then put the decimal point. The last one is negative 2 and 7 over 25. I think you can do it now. 25, I can multiply it by what to get 100? It's very easy to multiply by 4. And also we have to multiply the numerator by the same number, which is 4. So it becomes 7 times 4 and 25 times 4. We can ignore the negative 2 now. Keep it as it is. Don't touch it. We are just working on the fraction. So here we have negative 2 and 28 over 100. 2 zeros, so 2 decimal places, 8 and 2. Here we have a property. The value of the rational number a over b doesn't change if its two terms are multiplied or divided by an integer, not equal to 0. And that's what we need to focus on it. Here, it's up to you to multiply by any number. 3 over 7, I can multiply it by 2, both of them, numerator and denominator, to get 6 over 14. The same, if you multiply it by 3 up and down, we will get 9 over 21. And then here we have many forms of the same fraction, and they are called equivalent fractions. Here, comparing and ordering rational numbers. Remark, the two rational numbers a and a are represented on a number line by 2 points, equidistant from the point representing the number 0 and on two different sides of its rational number. A is opposite of a rational number a and vice versa, to do the opposite. Example, the two rational numbers 3 over 4 and negative 3 over 4 are represented on the number line as the following figure. As you can see here, the 0 is in the middle and 3 over 4 to the right because it's positive number. Then negative 3 over 4 is to the left of the 0 because it's negative. And all the positive numbers are to the right and all the negative numbers are to the left of the 0. Example 1. Represent on the number line each of the following rational numbers. How can we represent 7 over 5? 7/5, I can simplify it to be 1 and 2/5. How do we know that? By long division, 7 divided by 5 is 1, remainder 2. We have to write the same denominator, which is 5, and the whole number is 1, then the remainder is at the top, which is 2. To represent it, I have 1 and 2/5, so it's greater than 1. Greater than 1. Here we have 1. I'm gonna move to the right to get 2 parts. And take care, here we have to divide from 1 to 2 to 5 parts. Why 5 parts? Because the denominator is 5. Here it is, 7/5. And then, question from EKB. The number 5/x minus 6 belongs to Q if x belongs to which one of all of this? We have to look at the denominator, x minus 6. I need to avoid the value to don't give us 0. So I can write all the integer numbers except 6. So the correct answer is C. That's all about our lesson today. Thank you so much. Bye-bye. See you next time.